A linear inequality in two variables is something like this. Y is greater than or equal to x plus 1. What we're asked to find is all of the points in the xy plane that make this thing a true statement. So like one way you could start this is by choosing a point at random, plugging it in, and see if it works. So I guess you could start with just, how about 0, 0? So I'm just going to check this off to the side. We have 0, 0. Does this point work? And y is greater than or equal to x plus 1. So we would put 0 in place of y and 0 in place of x. We get 0 greater than or equal to 1, and that is false. So all that means is for this spot 0, 0, you don't want to use it. All right, let's try to find one that might be true. How about the point 0, 1? So I'll just go up one spot. So we'll check that one. 0, 1. Does this work? All right, I would put 1 in place of y, 0 in place of x. I get 1 greater than or equal to 1. Well, that's true. I mean, they're equal. It's not greater than, but that means I would mark this spot. I would definitely want to use this point. And the thing to point out here is that this is actually on the line y is equal to x plus 1. So once you make that observation, a good way to try to solve a linear inequality is to ignore the inequality part of it and just focus on, well, what about just y is equal to x plus 1? Every single point that lies on this line has to work in this particular inequality. So I'm just going to graph this thing. I guess I'll do that in blue since I have that over here on the left. But this line has slope 1 and a y-intercept of 1. So I already have this point 0, 1 located here. A slope 1 means I would go over 1, up 1 to give me a second point. And the line looks like this. So all of those points that lie on the thing I just drew make the inequality true. The thing is that there's going to be more, because it's not just where does y equal x plus 1, but where is y bigger than x plus 1? So I found a point where, it doesn't work. I chose 0, 0. The thing to point out is that's actually lower than the line. So maybe I'll pick something that's going to be greater than the line. It could be anywhere. Maybe, how about this spot? I'm going to choose -5, 5. I want to see if that works. All right, so I'm going to check -5, 5. In my inequality, 5 would go in place of y. -5 would go in place of x. I get 5 is greater than or equal to -4, and this is true. But, it's not equal. It's strictly greater than. This means that the point -5, 5 works. I would want to include this in my answer as well. So the takeaway is going to be, for any linear inequality, focus on the line itself, and then there's only two possibilities. Either it's going to be all of the points on one side of the line, or all of the points on the other side. Since I have one over here that I know works, likewise I have one here that I know doesn't, the answer to this is going to be all of these points that are above the line. So that's our way of stating the solution to the linear inequality. You can draw the line itself, and then however you want to mark it, just kind of shade in, it's everything that is on this region of the xy plane. So you can even check it. All of these points will work no matter where you pick and plug that into this, it'll be true. Whereas everything down here will be false, so I don't want to mark those. So now that we have this strategy for solving a linear inequality, I think I'm just going to, look at the line, graph it, and then decide am I above it or below it. So let's see. All right, so the line itself is 2x plus y is equal to 8. I would subtract 2x from both sides of this, changing it to y is equal to -2x plus 8. Now I can use the slope and the y-intercept to get the entire sketch of the graph. Let's see, the y-intercept is 8, so that's here. The slope is -2, so I'm going down 2 and over 1. And my line is just the equation that goes through those 2 points. All right. So now that I have my line, the only thing I need to decide is, okay, is it going to be this region of the XY plane or is it going to be this region? And all we need is to choose one point to verify this. 0, 0 is typically a really good point to use because it simplifies in the equation very well. So I'm going to choose this spot. If it is true that 0, 0 works in this inequality, that means all of the points on this side work. If it's false, that means it's not this side, and therefore it has to be all of the points that lie in the other region. So let's just check this one spot. So I'm specifically choosing something that is not on the line. So I want to check 0, 0. Let's see, you get 2 times 0 plus 0. Is that bigger than or equal to 8? And no, that is false. I get 0, and then I have 8, and this is clearly a false statement. So all that means is, okay, this point didn't work. None of these points are going to work. I will then just kind of mark that, okay, we're shading in this region is all the points over here that work in this inequality. Okay, for example 2, same idea. I'm given a linear inequality with two variables and I want to see all the points that work in the xy plane. The difference here is there is not an equal sign. It's just strictly less than. So this is going to change the problem just a little bit. Our approach is still going to be the same, where if I can figure out where y equals negative x plus 4 is located, I'm going to choose either side of that line. The difference here is, though, since there's no equal sign, I don't really want to include this line in my answer. The way I'm going to mark that in the xy plane is by using a dotted line. It's just my way of saying the line is the barrier. I'm just not using any of the points that fall on it. So to graph negative x plus 4, 4 is the y-intercept. I know the slope is negative 1, so if you want to just list a bunch of points, it has to be all of these. So to indicate that the line is the barrier, I'm just not using it. I'm going to just kind of continue to mark this with a sort of dashed line. So there's my barrier. I want to choose either side of it, but I don't want to include the line itself. So let's see. Okay, I'm going to pick a point on either side. It doesn't matter where it is. It could be 0, 0. That would be fine. So why not? I'll just go to 0, 0 and say I'm going to plug this in and see what happens. So we take 0, 0. We're checking this. 0 goes in place of y. It also goes in place of x. So I have 0 is less than, I just have 4, and this is true. So it is true for the point 0, 0. Therefore, it has to work for everything that is in this region. And this is the solution to this linear inequality.